Have you ever been working on something, a project, a document, maybe some code, and you're making changes, or really probably your AI assistant is making changes for you. And then at some point you realize, I really liked that version about 3 versions back, but you can't get there again. You're kind of stuck. Yeah, we've all been there. But there's a tool that completely solves this problem. It's called Git. At its core, Git is a tool that tracks the changes that you make to a project. It keeps a complete history of every change you've made, when you made it, and why you made it. It lets you get back to any previous version whenever you want. Today I want to show you how it works because it's much simpler than it sounds. And if you're already using an AI tool to work with files on your computer, like Claude Code or Cowork or Codex or Gemini or whatever, you're already a lot closer than you might think. Now, one quick thing before we dive in. You're going to hear me talk about 2 tools today, Git and GitHub. I used to think they were 2 versions of the same thing, but they're not. They're 2 really different tools. But you're probably going to want both because they work together and they both have different jobs. So today I want to give you the mental model for both using an actual project and show you how these tools work. You don't need to know the exact commands. Your AI agent will handle that for you. You just need to know what these tools can do and how to work with them. Both Git and GitHub are free. You'll need to create an account on GitHub, and on your computer, you'll need to install Git and the GitHub CLI. Claude Code or your favorite AI tool can help you install both. I'll put a link to the instructions in the description below. All right, let's get into it. So this is my brand new project. It's a web page. All the files live right here in my project folder. If I delete this project folder, my project is gone. If I delete this file, I can't get it back without asking Claude to recreate it for me and hope that it's the same thing. If I make changes, there's no version tracking. There's no way to get back to the state it was in a week or a month ago. So let's fix that. We're going to use Git to create a repository, or you might have heard it called a repo, right here in your folder. This just means that version tracking is turned on for all the files in your project. It's not going to create a copy of your code anywhere else. It's just something that's turned on right in your project folder. So currently, my project is just a set of files. Once I ask Git to create that repository for me, I've got my same project, but tracking is turned on. It'll create a hidden file right inside of my project that keeps track of all the changes that I make going forward. So to get it set up, I'm just going to ask Claude to do it for me. Can you initialize a Git repo for this project? And that's it. Git created a hidden folder inside my project that it's going to use to keep track of my changes going forward. I don't ever need to do anything with that file. It just lives inside my project. It's kind of like Git's filing cabinet. All right, so the structure has been created, but there's nothing saved in there yet. I need to do what's called a commit. This is a save point. You can kind of think of it like a checkpoint in a video game that you can always get back to if you get into trouble down the line. Right now, I've got essentially an empty repo, so I need to let it know I'm ready to make that initial commit. Claude is smart enough to know that's generally the 2 steps that you would do in tandem. It's asking me if I want to make an initial commit with the current files. Yep. All right, so at this point, it's saving a snapshot of all of your files, and it's going to add a comment to let the future you know exactly what changes or files are in this commit. A simple single-page app with a centered blue button. You can tell it what comment you want if there's something specific you want saved in there, but generally I let Claude be in charge of the comments because it's a lot better at remembering all of the changes that I've made, especially if it's over a longer period of time. And I find it does a much better job with those comments than I probably would. All right, so that's done. That's the first checkpoint. I can keep working from here, make a bunch of crazy changes, and if I decide I don't like any of them, I can just tell Claude, I want to go back to my last commit point. And it takes care of cleaning up the mess and getting me back to a clean, stable code base. All right, let's go ahead and delete that button. Okay, so I've made some changes to my code and I will go test it out. Ah, shoot. All right, so I've completely deleted the button. That's not at all what I want. I did not mean to do that. Can you get me back to the last commit? And it's going to roll back. It's going to check out the code where it was at the time of safety. Okay, whew, thank goodness. I could never have gotten back there on my own. So that's Git at its most basic. It's a system that lives inside your project folder and tracks changes over time. A repo is just the project with version control turned on. A commit is just a checkpoint in time that you can always come back to. All right, so that's pretty simple, right? And that's really the foundation of what Git does. But next, we're going to go one little step further that will allow you to be much more flexible and creative with your changes. All right, so everything I've done up until this point is on something called main. Think of this as the main branch of your code, like the trunk of a tree. This is your stable working code. You might even think of this as your production version of code. As you move along in time, you create these commits or checkpoints where you've got saved files that you can go back to. But here's the thing. You might not always want to work directly on main. You might want to experiment a little bit. And what if you want to try something out and commit the changes along the way without touching that stable version of your code? That's where branches come in. A branch lets you take a complete copy of your project from main and work on it completely separately. Main stays exactly as it is, and your working development branch is a place to go play and experiment. You can try whatever you want, make any crazy changes to the branch, and it never affects main. If the changes you make turn out not to work at all, you can completely throw out that branch and walk away. Main never gets touched. Let me show you. Let's create a new branch. Let's call it dev branch. There's nothing special about calling it a development branch. You could call this anything you want. It's not uncommon to name it after the change that you're making. So if you know you're doing a bunch of UI refactoring, this might be the UI branch. If you're making changes to the database, this might be the database branch. You can call it anything you like. All right, so we are now on the dev branch and we want to make some changes. Can you make the button red? And I'd like the label to say branch. All right, let's make sure it worked. We're going to refresh. Great. That's awesome. Let's commit that change. All right, so we've committed that change. Here's where we're at. We're working on the dev branch and we've got a commit on the dev branch. Main is completely unaffected. And just to test that out, let's make sure. Let's go back to the main branch. All right, so we're back at main. And we can verify that it's untouched. Nothing we did on that development branch affected main. And that's good because maybe while you're working on that development branch, there's something that needs attention in your stable code base, in your production code that maybe needs a small tweak or needs to be changed. Let's update that button label to say stable. All right, great. Okay. So that production problem is taken care of. Let's commit that change. All right, good. So that change is safe. Now let's go back to the development branch. All right, we're back on the dev branch. We can see it here. Everything's good. And here's where we're at. We committed that change on the development branch. Then we hopped back over to the main branch. We made a change that needed to be made. And we committed that change. So now we're in a state where maybe we've made some changes over on the development branch that we're happy with, and we want to bring them back into the main branch and keep them on that code of record branch. That's what's called a merge. It means you want to bring this code branch back over to main and make it one main branch again. So all you have to do is tell Claude. All right, I think we're ready to merge this dev branch back onto main. All right, so you might have spotted this problem before we even got here. There is a conflict. I tried to merge the development branch back to main, and we had a conflict because the change I made in this commit is in direct conflict with the change I made over here on this commit in main. Now, A lot of the time, Claude or your coding agent will handle the conflict for you because it has the bigger picture. It's the one doing the coding. It knows what needs to be changed. But in this case, I asked for very specific, distinct changes between the two. So it's not sure what to do. It needs to ask me. The button label on main says stable, and on dev branch, it says branch. The red color and other styling from dev branch merged cleanly. Now, if you're wondering why it's not calling out the color as a conflict, that's because at this point, there was a commit point with the color. I checked out a branch, I made some changes over here, and nothing I did over here changed the color from this point. So it's assuming that part of the changes I wanted to make on this branch were color. It's not in conflict with anything else that was changed since the branch was created. So it's going to assume that that one was intentional. But the thing that wasn't intentional is that the label changed after I checked out the branch and changed the label over here. So that's the direct conflict that it's seeing. So in this case, I want to keep that label that says stable. And you can see in the comments, merge the dev branch into main, keep the stable label. Merge completed. We now should have a red button with the stable label. It's exactly what we wanted. We ran into a conflict. We didn't need to enter any of the technical commands that Git would ask for on a command line interface. We just told Claude what it was we wanted. And once we've told Claude how to resolve the conflict, we merge that branch back in and it creates a new commit, a new checkpoint for us. All right, so everything we just did, the repo, the commits, the branches, the merge, that was all Git. And all of that happened right here on my computer. That's the key thing. Git is local. And that's important. Git is not a backup. It's not storing a copy of your files somewhere else. It's all local. If you delete your project folder by accident, everything's gone, including the repo. If your hard drive dies, it's all gone. And that's why GitHub exists. GitHub is a completely separate service. It lives in the cloud. It's a website that stores a copy of your Git repository in the cloud. So now your project can exist in two places, on your local computer and safely backed up on the cloud in GitHub's servers. Now, GitHub isn't the only service that does this. GitLab and Bitbucket are a couple other services that do this, and Git works with all of them. But GitHub is one of the biggest ones, and it's the one that I use. So that's the one that I'm going to be talking about today. When you push your repository up into GitHub, you can make it private or you can make it public. If you make it public, anybody can see your repository, they can make copies of it, but they can't push anything back to your repo without your permission. They can make a request and you can take a look at that, but anything that they do is on their own copy. You're not allowing people to go in and alter your code in any way. Now, if you start poking around GitHub, you're going to see a lot of other options. There's pull requests and issues and project boards. There's a lot of tooling for teams and project management to use on collaborative projects. But most of that you can ignore. If you're just a team of one, like I am, you don't actually need any of that stuff. I don't use most of it. For us, GitHub is just a cloud backup and a safety net in case something goes wrong with our hard drive. All right, so how to get your code up there? This is where you do need to make sure you have an account set up on GitHub, and you'll need to install the GitHub CLI on your computer. The first time you ask Claude to do something with GitHub, it will ask you to log in and make that initial connection, but once you do that, you should be set up going forward. So we just go back to our project. Hey, can you push this to GitHub? I'd like a project called Big Button. It'll ask you if you want it public or private, and possibly your username. And there it is, my Big Button project, safe and sound, living inside of GitHub. That's it. My local repo is now in the cloud. If anything ever happens to my hard drive, or if I start working on a copy and get so carried away that I forget to make a branch, and I just want to throw it out and start over fresh, I can just go to GitHub and ask to make a clone of my repo and start with a fresh, clean slate. It'll create a brand new folder right on my hard drive with all of my code and all of my history. So think about what just happened. Everything I did, creating a repo, asking for changes, asking for commits, merging my branch back into main, I did just by asking Claude to do it. I didn't need to know any of the Git commands. So you already know enough to do this. You can start now. And just a note on how I personally work, I get enough code to get a stable working version, and then I push it up to GitHub. And then if I'm smart, I'll create a branch, start doing any work that I have to do on there. And then once I'm happy with it enough to push it back to main and commit it, that's when I'll push back to GitHub again. That's definitely not the only workflow. It's just my workflow, and it's a decent place to start. If this was helpful, hit that like button, hit that subscribe if you're interested in more videos like this. All right, that's it for today. Thanks for watching. I'll see you next time.